edition of the Brazil-Korea Forum. My name is Rodrigo Higg, and I'm one of the coordinators of the Brazil-Korea Forum. At this moment, I would like to thank Professor Madhusudan from Wozong University and College for accepting our invitation to participate in this event. Unicinos has elected South Korea as a strategic partner, so maintaining a partnership with dozens of institutions in that count of more than 10 years. In this way, the Brazil-Korea Forum is a traditional international event that celebrates the partnership of research, science, and innovation between the countries Brazil and Korea, together with other partners such as USA and Germany that have joined us in the cooperations over the time. Since 2011, the forum has been active in the education and training of students and professors, so focusing mainly on the topic of semiconductors and its extension to Internet of Things, sustainability, and healthcare areas. The partnership between Brazil and Korea is fruitful and has already resulted in the creation of the Semiconductors Technological Institute at Unicinos, as well as in a close academic mobility at both undergraduate and postdoctoral levels. This year, in particular, the Brazil-Korea Forum takes place entirely in a virtual mode through a cluster of workshops and panels. So, at this moment, I would like to invite all participants to watch a short video about the main achievements of the Brazil-Korea partnership.
Com sua primeira edição em 2011, o Fórum Brasil-Coreia consolida uma parceria de quase uma década entre Unicinos e instituições da Coreia do Sul, com o principal objetivo de compartilhar conhecimento entre pesquisadores na área da tecnologia. O evento estimula a inovação e desenvolvimento de produtos. Desde sua criação, o Fórum teve como principal tema a cadeia de semicondutores, a partir das relações criadas entre os países com o protagonismo da Unicinos. A área se consolidou com a instalação da empresa HT Micron no Tecnocinos. Ao longo dos anos, o Fórum possibilitou diversas oportunidades para a comunidade acadêmica, desde publicações científicas conjuntas, ações de mobilidade estudantil, dupla titulação na pós-graduação, projetos de pesquisa no âmbito da indústria 4.0, até a capacitação de recursos humanos para o setor tecnológico. As conquistas do Fórum Brasil-Coreia se ampliaram com o tempo e mudaram parte da matriz econômica da região. Além do estímulo às startups na área de saúde e tecnologia, o Fórum possibilitou a criação do Instituto Tecnológico de Semicondutores ITT Chip, a partir dos programas de pós-graduação em Engenharia Elétrica e Computação Aplicada. Em 2019, a integração entre pesquisadores brasileiros e coreanos, ITT Chip e HT Micron, criou um marco importante para a área no Brasil. Primeiro chip semicondutor para o mercado de internet das coisas projetado no país. Perspectiva de uma expansão e consolidação das suas relações internacionais, Unicinos mantém uma contínua ampliação do Fórum com a participação de países como Estados Unidos, Alemanha, Austrália, entre outros. Movimento estratégico que torna o pioneirismo uma tradição, fazendo da inovação uma cultura que a Unicinos, universidades brasileiras e coreanas, ter público e empresas constroem, agindo localmente e pensando globalmente.
So, in this evening here in Brazil and morning in South Korea, we'll have a workshop considering our cooperation with Wozong University. In particular, here we have Professor Madhusudan for our workshop. And so the rules of the workshop are, first, we have the part of Wozong. So Professor Madhusudan has some slides to share. And after that, we have the Unicinus part. And finally, we have a moment for discussions about collaborations, articles, and projects. So in this moment, I would like to invite Professor Madhusudan for sharing with us your presentation.
Okay. That is, can you see my PPT slides?
Yeah, perfect.
Yeah. Okay. Good evening in Brazil and good morning in Korea, and everyone's welcome. So thank you very much for inviting me this workshop, that Korea Brazil Forum, 8th Forum. I will happy to just going to share. I'm going to talk about analyzing the future of distributed system and blockchain networks. So as before that, as our theme of this forum has a digital transformation. So I'm just giving to some overview about the how much digital transformation is going on. Then we discuss about the some blockchain development is going, and finally we talk about the in the future perspectives, what is the chances and what is untouched or untapped the blockchain technologies in this digital era. And then I just give that one blockchain use case examples, and then finally I'm going to summarize my whole talk. So about as a digital transformation, as we know, there is everywhere is now in each and every field is going to digitalize currently. So as we can see, that is this diagram is shared by the McKinsey, adopted from the McKinsey Global Institute. So they have a talk about the what is the technology trends and leverage digital, how to they are changing to digital storm is coming to us. So exponential technologies are fueling these storms. So like big data analytics, sensor actuators, mobile technology, and cloud computing, natural user interfaces, ubiquitous connectivity. They have like anything as a services. The middle layer is the social metrics, big data, advanced analytics, automation for knowledge, and the Internet of Things, integrated digital of and physical experience. So they improve our experience, enhance our productivity in the industry point of view, and find the new business models too. So here there is some components about the digital transformation. There is a trust. They provide the protect our data and data, people and organization informations, collaborations that create a productivity workplace in embraces, and diverse work style, mobility that is enable our work people and get things done anywhere. Intelligence that provide the insight of the drive fosters and better business decisions, and analytics they have give the transformation of our digitally to our company data into rich visual and analytics for the better decision making. So these are the some elements of those components that trust they have required for the integrity, intelligence, security, transparency and control, privacy by design, compliances, leadership and collaboration. We have already working on these collaborations things. So we have the email and schedule, then create and share and find, call and meet, connect with the engagement for this, like as our forum is going on like Korea Brazil forum. So these things is already working on that type of collaboration. So mobility, that is a work from anywhere, access from devices, manage and secure identity, always up to date. Like that is the good example for the we are talking each other in the digitally, that when we are presenting to our work, presenting my works to all of you. So that is the mobility. Anywhere, anytime we can discuss our collaboration and trustable, we can increase these things. Intelligence, that is analytics for the everyone, and discover relevant content and people, improve personal effectiveness, works for you, and in analytics that we need to make the digitally, if we have, then we make that analyze our whole information and data digitally, and then transformation, and then we make the decisions based on our analysis. So gain the insight into the how you spend your time at work set and track goals to improve how we use our time, understand our top connections and recent interactions, add our important context to stay up to date. So these all comes from from here that fourth industrial revolutions, that is the biggest typhoon is 21st century. So you just give that overview. I believe that everyone has understanding know about that first and fourth differences between the first, second, and third and fourth revolutionary engineer this industrial revolution. So as we can find, fourth industrial revolution, we have to this digital formation, AI, artificial intelligence, with software, information, big data, IoT clouds. This all is combined in the digitally transform nowadays. So now we just discuss about the why we need to blockchain in what this digital transformation and what is the distributed system is required. So as we can see, this blockchain is provided decentralized. There is a security, privacy, distribution, and there is no any central authorities. So like that is some there is the examples of the centralized. There is a one node does everything, distributed nodes distribute works to sub nodes, and decentralized. Every node is connected to peer by peer, and they work there independently, and they will discuss with the other peers also. So this is the hype cycle for the blockchain businesses in 2019. So as we can find that the blockchain is nowadays is too much working on this blockchain for in supply chain, blockchain for CSP, and this in education field, education reward. This location, this top is the smart contract, blockchain, insurance, supply chain, and these are the most focused areas from last years. So blockchain adoption approach, we have to how can we adopt the blockchain in any applications, not only for some specific one, anywhere where we want to use some decentralized functions and decentralized activities. So we need to discover, there is understand the technology, identity, which problems need to be addressed, access process, gaps, and possible ways of re-engineering, realignment about the stakeholders who are involved in our business and our technologies, which technology we're going to use or which application we're going to use our blockchain. So we realign and stakeholders, workshops, explaining intent of approach and benefits. Second, we need to also think about to analysis about the whole process. This blockchain is really feasible for our applications or not. So we can check that feasibility analysis, that is operational effectiveness, risk assessment, impact to existing system, regulatory compliances, and assessment. Then we define the problems, we design our problems, how can our blockchain technology going to be help, and we need to think about to design decision, design, own, and leverage existing platform. Start with the non-permissioned public ledgers, move to private permissions ledgers or consortium. Define the distributed network, roles, smart contracts, and we also need to define the expected parameters, what type of parameters we require to our applications where we are going to adopt this blockchain technology. So, and the final, we have to implement. For this, collaborate with others, design for interoperability, review standards, partner with the fintech and the other applications, build the stack, start with the small processes, sandbox test, proof of concept, and for this consensus algorithms, we need to think to how those mechanism we need to change, those algorithms we need to modify it according to our applications, and through testing for the transaction stability and security scalability. The last we have to use for the execution, second last, that is the execution. So is roll out the plan, identify stable geographies, and gap assessment and immediate fixes things. So that is our whole blockchain adaptation approach. And next we have talked about to decentralize app, how to de-app works. So it's just as an example about defining the decentralized applications. So the application that uses smart contracts provide a user-friendly interface to smart contract, and component for the smart contract we need to file and web user interface like front end and back end side. So write the smart contract in high level language, we compile, run the smart contract and code, and then deploy a smart contract on the blockchain platform. Then we create the interactive web applications with the smart contract for the decentralized applications. So benefits of the blockchains. What is the benefits? Like nowadays, so many people are thinking that blockchain has that blockchain boom is going back, or we can say that going drop a lot of things. But as I believe that things, blockchain has it still have a lot of scope. As much as we application things, any applications like e-governing, voting, even the farming, we can use those blockchain things, blockchain technology. So benefit is they have a transparency. All updates to data and transaction must be verified by other networks. Then we have to again transparency, but not transparency. That is the consensus, is the typos. So any users can check if the system is working correctly, which transaction is confirmed by the verifiers, who are the peer users of the blockchain. Privacy, that is the despite the blockchain being a decentralized system with the high level of transparency, all transaction and interaction between the network members are anonymous. And integrity, then we can blockchain give the guarantees that data cannot be changed, cannot be modified. So these are the basic ideas of basic benefits for the blockchain in any applications. Another technical things like they have a decentralized peer-to-peer network. That is the another things I'm talking about here, just over of the for the normal people who don't know about this too much technologies. We can discuss those technologies things with we can talk about those things, benefits for the blockchain. So we have still, there is some untapped or untouched issues in the blockchain. They have a lot of scopes in the blockchain for the research purpose. So as a scalability, slow and cumbersome environment, there is the cost, energy consumptions things, the crime connections. A lot of people are worried about this. Everyone, when like ransomware and those things is happening, they are asking for the Bitcoin and cryptocurrencies things. So they have people are thinking about these blockchain technologies using only for that crime. They have some crime connections. So privacy, security, and regulations, rule and regulation. There is no any standard rule and regulations for the blockchain. So that can have also very big side for the research. And we have to public perceptions. We need to modify about the public perceptions. Let's discuss one by one each untouched issue. First, like scalability issue. So scale in blockchain means the transaction that can be followed up per second. So if transaction is stored in the many block, then it has the search of many blocks, which result is time consuming. So we need to find out some solutions. We need to do that some solutions that there can be. We don't check that every blocks. We just get it the information and we do the very quick process and we easily scale to these situations for our blockchain. We will scale for that purpose. Scalability issues. Second, we have to slow transactions. If the number of users increases in the network, similarly the transaction process is a decrease. As an example, we have to source and destination. So if they have a clear click on the lot of members in the blockchain, they are doing miners and nodes, verifying those things. So it will require more than 51% people are consensus methods, like 51 people are agree on that some particular transaction. So it will take that so much time to verify that transaction. Third, we have to blockchain environment costs. So to run the complex algorithm for the consensus and proof of work validation, the computer needs to large amount of energy. So that is also big issue in our blockchain technology. Third, that about the crime connections, irregular reputation. About that, many ordinary people still think blockchain is the crypto world, or that normal common people, they are who don't have a very big idea about the technology field or anything, so they have some issues. Okay, blockchain, and they just think about the Bitcoin, and they think about the cryptocurrency, that crypto world. So from that point of view, they are thought about, okay, this is the not that much reputed technologies for their mind, so we need to do that to improve those things also. So the only thing they remember is Bitcoin and many controversies around them. Crypto has a negative image, and due to its link with the scam, hackers have been using the fraud activities. That is the crime connection on irregular reputation. Third, next we have to data privacy. So the public ledger system may disrupt their privacy. The blockchain network is based on the distributed ledger, where all participants have access to the data on the platform. As such, the lack of data privacy and that competitors, there is subsequent many potential users shy away from the technology for fear of losing their competitive advantage. So there is a data privacy that is a big issue. And for example, in the node have a 10 nodes, and between those 10 nodes, their transaction is going. So as we can say, those transaction, they have changed their ID, their personal information, but what information is stored in the ledger, that is then always in plain text, just they hiding their personal information. So we have to think about that whenever we going to talk within the network. So those our with the personal information, our transaction information must be also encrypted. So people just verified the legality of the node, not legality of those transactions. So it will be more useful about more useful for our data privacy things. And if there is some link of some weak link within the node, so if any one node can be compromised with the attackers or compromised with the outsider of the node of our blockchain network, so he will get the whole information about the everyone's node, because every node has stored the similar data, what transaction is going on. That is thing. So data privacy is also one of the issue in the blockchain. Next, we have to security. So that the security is still lacks in the many ways and needs to be upgraded to the great extent. As example, we just give that, like if any insider nodes get compromised with the outsider node, so it has chances to be he will get it. If any attackers can be involved in node, so it's possible that can be destroy the whole. He will get it the whole information about the whole blockchain information. So we need to think about the even though when we start the transaction. So transaction must be the using to encrypted form. Like some nowadays some research is going on the homomorphic algorithms. So the main message and transaction is the encrypted form, but with their we have for the consensus that mathematical problem will be solved by the miner. Miner can be just verified the node is the legal in our network or not. That things. Next, we have to regulations. We don't have any standard rule and regulations by those things. So like lack of standardizations, due lack of the mass adoption, it resists of the technologies to adjust the industry to collaborate things, but still some of industries are there working very well try to implement this thing to blockchain in their own environment, in particular environment for their industry environment. Next, we have to public perceptions, like lack of public acknowledgement and marketing. Common folks should be educated on this new to pursue it. Like 2014, 2015, there is initial use case and capability of assessment. 16 to 17, the adoption begins for the cryptocurrencies, and we believe that 2018 to 2024, to new service providers and models emerge, the deployment go viral across the numerous. 2025 till there is get the maturity of blockchain adoption in the considered mainstream and integral to the capital markets ecosystems. But they are working on this blockchain things, but as I mentioned, they have also still some not the confirmed and confidently they are implementing their publications. They are just trying to is going on the practice mode. And next we am going to talk about the what the protection we can provide, the traditional versus blockchain protection. And for example, in the vehicles, I consider about the self-driving car, about things. So in here, vehicle has so many problems like key fob hacking, oversight, third-party apps, personal data security, malware exploit, and spam, and advertising, vehicle-to-vehicle communication issues, vehicle to infrastructure communication problems. Some hackers can be modified things. So they have some centralized architecture, heavy on the resources, unable to protect data, that is the mobile, unable handle to large amount of data at the same time, no access to vehicle history, no distributed network. So blockchain technology provide to us the decentralized architecture, low on the resources, able to protect data, that is mobile, able to handle large amount of data at the same time, and access to the vehicle history, distributed and with the also there is a distributed network. So that is the one scenario of vehicle. Yeah, so this is the current scenario of our traffic without the blockchain. We can see, so vehicle are depending on the green signals and red signals, right? What vehicle is when the signal is coming and going. So there is some accident is happened. Is once accidents happen, there is a lot of vehicle going to be stuck and traffic going to be problem. So we have to propose this blockchain traffic scenario. So as we can see in the video, vehicles are not about any signals based on the signals, traffic signals. They are just communicating each other, and according to their communication and based on their timestamp and all things, they decided which vehicle is going to be moved first from this intersection and which side vehicles is going to be moved. So that is the seamlessly transmission traffic going ongoing without to disturbing to anyone else. So this is the our proposed blockchain technologies. So from here, as someone has a very this work I'm working last 2 years, from the 2016. So they have some issues to in starting when I started this implementing blockchain in the vehicles, autonomous vehicles. They have issues about to the vehicle are not that much efficient. So this blockchain is we proposing for the self-driving car. And second issue is that there is a lot of traffic. Then how can we manage this blockchain server? How going to be they are managing these things? So for that purpose, we have proposed, and that we already patent that thing. Patent is done, accepted our patent about to the we divided in the two blockchain servers. Local, that means the who's the talking about in this local regions, who managing the local regions, and one is another main blockchain. And these are the main blockchain where their data is stored for the permanently event based. If something is happening in this area, this region, those information will be stored the particular from the long time, as much as like lifelong for this vehicle. And next, this local blockchain, they are storing only for the some data and overriding according to because they have some fixed storage powers according to that. So these are the our ideas we had did for the patent that idea. So next we have. So next we have the benefits. What the benefit we can use for utilizing the same push for the blockchain technology solutions? It is increase the number of passengers, increase the amount of goods, increase the average speed, and decrease the congestion, decrease the accident, decrease the carbon footprint, and make it the seamless transportation, seamless vehicles is going on that all side. So, but still they have some big issues in the general blockchain. If we use generally blockchain in autonomous vehicle, like consumption of significant amounts of power, requires large size data servers to manage information in real time. So storage of data needs to be stored for the long period of times, like more than 2 years, and management of data exchange in the mobile and dynamic environment. So they have still we have a lot of research scope in this field, and in the like blockchain in autonomous vehicle as examples. So now I'm going to give that my final remark about to my this whole talk. So as we talk about the blockchain technologies, we have to overview of the blockchain adoption approach and decentralized applications, benefits of applications. We have blockchain untapped issues. There is a scalability, security, data immutability, energy consumption, and rate of interoperability. And according to we discuss about the autonomous vehicles, blockchain simulation, interaction, use cases, blockchain technologies based on autonomous vehicle, and research is still we have a lot of research scope in the blockchain also, plus blockchain plus in the their application about autonomous vehicle according to like security issue, privacy, scalability, and consensus algorithms, and quantum resistance the issues. And yeah, thank you very much for listening. That's all overall my talk. So yeah.
So thank you very much, Professor Madhusudan, for your great presentation. So a lot of points for collaboration. So I will discuss about this in the second moment. In this moment, we have the presentation of the Unicinos team. So we have prepared some slides about our group named Software Lab, and we will discuss in this moment. So in this moment, I will share the presentation.
Yep.
In a moment. Can you see the presentation?
No. Can I need to stop my presentation first, I think.
No,
I
need
to
stop.
No problem. I will try again.
Can I stop my sharing?
Yep. Now we can see your screen.
Perfect.
Yes.
So in this moment, I would like to invite my colleague, Professor, on a moment here. Oh, sorry. I would like to invite my colleague, Professor Cristiano Costa. So we have divided our presentation in 2 moments. The first one, we are talking about healthcare applications, and in the second moment, we will talk about resource management and industry 4.0, both points related to blockchain applications. So, Professor Cristiano.
Hello, everyone. Good evening. It's very nice to be here, especially with Professor Madhu. And I will talk a little bit about our software innovation laboratory. I'm the manager of our laboratory, and we work basically on applied research. Many or most of those research in partnership with industries, hospitals, and enterprise. So we have been working in the field of applied computer for 16 years, and in this time, there were a lot of students involved in undergrad, grad, master level, and PhD level, and around 200 students and around 30 software and patents generated during these times. You can see at this slide some photos of our lab. We have, for instance, a simulated operating room that used in a recent project. So here we have some of our current partners in the health area, including many hospitals from our region. Probably the most important hospitals from our region are already our partners, and some companies like Dell and Siemens, and also some international universities. So this is an overview of all the areas that we work on the software lab. And the main areas are the area of Internet of Things, artificial intelligence, distributed applications and cloud computing, and then mobile and ubiquitous computing. And finally, well, those are the vertical areas, and you have the horizontal areas, which are the application areas. And well, I'll talk a little bit about the health, and then Professor Higg will talk a little bit about the Industry 4.0. So here are some of our current projects in the field of health informatics. The first one is a project that we developed with Siemens Healthcare in Germany. And this project consisted of monitoring the workflow of people inside a hybrid operating room. What is a hybrid operating room? It's an operating room with image equipment and also the traditional medical equipment and operation instruments. So besides having the normal components of an operating room, we have a lot of image systems. And these rooms used to be crowded with a lot of different physicians, nurses, sometimes students. So our project consisted in monitoring this workflow, combining RGBD cameras and UWB ultra-wideband sensors. And we created a 3D space. And in this 3D space, you could visualize the room and see every path of each person. Like we could see a heat map of the movements of people in the room. So we could control all things related to the workflow of the operating room. The next project, we have a cooperation with VIII, which is the German Research Institute, and CAPS, which is the Brazilian one. And this project also involves CNPq and other hospitals and companies. And we work with rethinking the hospital bedroom and integrating all the data inside the hospital bedroom in fog computing. And this fog computing uses some machine learning analysis to predict the outcome of the patient, the severity of the disease, and combining all the available context data to predict the outcome and the resource that we will need at the hospital. So inside the hospital, inside this project, we also work first with the prediction of vital signs, and then we are proposing an intelligent risk score. At health, many people use risk scores. Many hospitals, many physicians use risk score to evaluate the severity of some disease. So we propose an intelligent one based on a random forest. We developed the first prototype using neural networks, and then we evolved to random forests in a way that we can explain to the physician why some prediction was made. Another project, and this probably is the most interesting, I think one of our PhD candidates, Fausto, talk a little bit about blockchain in the health area later. The idea is to use blockchain to integrate different health records in different health providers. So we have different hospitals, clinics, and each one has a node of the blockchain. And using this blockchain, they share the health record data from different patients. So we started this cooperation with Hospital de Clínicas de Porto Alegre, which is our main university hospital in the state. And we connected different systems, health information systems, and exchanged information using blockchain. And we also have an important internationalization project in Unicinos, which is the PRINT project. And the PRINT in the applied computing area has two main projects, one related to health and the other related to industry that Professor Higg will talk a little bit later. And in the health area, we work with different applications. So in this first slide, we show a little bit about the quality of service that you can integrate hospital devices and work with the quality of service needed for each device and each application. The last project that I will present today is a very recent project. We started working with this at the beginning of this year, and it's a CAPS-sponsored project. And it's a partnership with the main hospitals in our region. We have a total 9 partners in this project. I'm the coordinator of this project. And this project is in the scope of COVID-19 and also employs blockchain. We use blockchain to create a distributed and intelligent communication system. So this communication system, as the previous one that I showed, connects a lot of different hospitals. But in this case, for the purpose of sharing data related to COVID-19, and on top of this data, we use neural network techniques to infer a lot of prognosis for the patient, and also management important information for the hospitals and the government. So this is the purpose of the project, which is called My Digital Health, Minha Saúde Digital in Portuguese, and is a brand new collaboration, and is a very interesting application of blockchain integrating the main hospitals in our region. So I give back to Professor Higg for continuing the presentation. Thank you.
Thanks, Professor Cristiano, for explaining us a part of our research in the area of healthcare. So the second part of our presentation, I will talk about computer resource management and architecture. So here, including the area of Industry 4.0. So in this first slide, we have cooperation also together with the healthcare area. So a cooperation with our hospitals, right? And here we are including the idea of cloud elasticity. So in one side, we have a lot of sensors and actuators, and in the other side, we have the applications, and in the middle, we have the middleware, and we must provide scalability for this middleware. For example, we have the FastTrack middleware, and FastTrack is a GS1 standard middleware, and inside this kind of middleware, for example, we have EPCIS model, and in the right, you can see that we are mapping this kind of model in a virtual machine, so we can enlarge and we can reduce the number of instances at real time in accordance with the application's demands. So our group is pioneer in the idea of employing cloud elasticity in many areas of applications. So here we have research in the area of precise agriculture. So the idea here is to combine sensors and actuators, the LoRa technology, together with machine learning, and especially we are talking about event prediction. So we have used here in this scope ARIMA prediction model together with sensors and together with LoRa prediction. So in the upper and in the right, you can see our prototype, including a solar shape, Arugula crop, sensor connections, Arduino board, a LoRa board, as I said, and a battery involving all the prototype. So here we have a slide talking about our project in the scope of Industry 4.0. The name of the project is Intelligent Factory, and here at Unicinos, we are running 2 international projects. So the first one is in the scope of healthcare area. So the coordinator of this first project is Professor Cristiano, and the second project that we have together with South Korea, for example, is in the area of Industry 4.0. So in this project, we have a partnership with HD Micron Semiconductors company, and our idea with this project is to employ proactive monitoring in order to get data from the sensors, and so the idea is to act proactively in order to minimize, in order to mitigate eventual problems in the company, in the clean rooms of the company. So in the left, you can see basically 2 approaches. The first one is a reactive approach, and the second one is a proactive, and we are working with the proactive approach by using historical data, so after that using data prediction in order to avoid a problem, because crossing the upper threshold, we could have problems, and then the idea is to avoid this crossing. And in the right, we have different types of sensors that we are using in the company, and especially in order to monitor all the machines and all the environment inside the clean rooms of the company. So we have different types of sensors, including electrical field, particles, humidity, pressure, vibration, sound, temperature, pH, dew point, and so on. So in the company in this moment, we have more than 200 sensors, and we are collecting this data at all times. So in this slide, we have a board that we have developed, particularly for the project. So the idea of this board is to integrate, to read data from sensors, both digital or analog sensors. And in this moment, we could think, okay, we could use an Arduino board, or we could use a Raspberry Pi board, but both Arduino and Raspberry Pi, they are not reliable for us. So we have developed our own board in the Semiconductors Technological Institute at Unicinos. And in the right, you can see a map of the company, and so how we mapped the sensors inside this map. And here, well, in the left, we have the visualization tool. We are using the Grafana tool. So we have different sensors, each sensor with a particular color, right? And we can see the status of these sensors at real time. So our project is running today in the company, and it is very useful for the managers in the company. And in the right, we have some ideas about our architecture. And the main ideas here are, we are using a hierarchical architecture. So in one side, we have client-server architecture that's not scalable. And in the other side, we have P2P architecture that's not easy to manage. And in the middle, we have the idea of using a hierarchical approach. So the other point that we would like to emphasize here is the connection between the node, the integration node, right, and the concentrator. So this connection between the node and the concentrator happens through radio frequency. So we are using a technology in which we can change the protocol, the communication stack at real time. For example, in the lab, I am using Bluetooth Low Energy, and in the lab, everything runs fine with BLE, but in the company, BLE could not run fine. So the idea is, okay, I am able to change the communication stack at real time, for example, to other kind of technologies like wireless and others technology. So here we have our research in the scope of microservices application. So after talking about microservices, it's important to talk about monolithic applications, and we have the problem of scalability and well, the idea of managing this kind of application. And so microservices follow the idea of service-oriented architecture. And in the left, we have an example of application. So for each microservice, we have deployed a load balancer, and then this load balancer is in charge of controlling the number of instances that can run the microservice. So this load balancer can enlarge or can reduce the number of instances in order to provide a good quality of service for the own application. So the main idea here is to avoid bottlenecks in a particular microservice. So we're talking especially about blockchain. We have our model named Elastic Chain. So the idea of this model is to combine cloud elasticity, IoT applications, and blockchain, right? In the bottom, we have our idea. So we can enlarge the number of nodes in the blockchain network at real time in accordance with the demands on such nodes. And here, a project that we have considering the idea of data prediction, IoT applications, and milk management on dairy cows. And in the left, we can see our architecture, and in the right, a real deployment of this research. And so here we have milk sensors, feeding actuators, and here also we are working with data prediction with the ARIMA model. And considering the smart cities scope, we have research on driver assistance, so avoiding rear-end collisions and detecting potholes. And here in special, the main idea is to reduce costs for end users. So in our research, we are using the own smartphone of the driver in order to control the collisions and the potholes. And also we have modeled a cloud architecture in this scope. Well, here we have also a blockchain project, and blockchain project applied to agrochemical products. So in Brazil, Brazil is a very big country, and Brazil is has this part of agriculture very developed, and it's very normal to use chemical products in the crops. But here also we have a problem, because you have a problem of applying so much products, and you have a problem also about disposal, and you have a problem about what companies are allowed to buy a particular product or not. So the idea is to use blockchain in order to map, in order to control this kind of application. And in the right, we have our architecture. In the green hole, we have a public sector blockchain layer. In the yellow hole, we have a a supply chain blockchain layer in a private sector. So a particular vendor has its own blockchain here, and in the upper its own blockchain here, and in the upper layer we have our foggy computing layer together with data prediction and data correlation. And finally, we have some publications considering the scope of our software lab research group, right? So we have publications both in the area of healthcare and industry 4.0. That's this is our presentation, and thank you very, very much. So in this moment, we have, I will stop my sharing here on a second. Yeah, that's it. So in this moment, Professor Madhu, we have a part for discussions and collaborations. So we have a book together, right? A book and a book chapter together. And also we have some articles together. That's very, very important. And as Professor Cristiano said, and I have complemented, we have here at Unicinos international projects, and we can collaborate further with South Korean institutions. And so I would like to see about your part. For example, can you receive a student, a PhD student in your university, for example, or could you receive a visiting professor in your university?
Current now, we have I need to discuss with our department head, and yeah, I think we can accept exchange student also from your university and as a visiting research professor too. So, but we need to be discuss about to our higher management. So once I will discuss and I will inform you to. But that is a possibility. There is no any burden and no any foundation and those things. So I think it is not any problem. We can accept the students and accept as a visiting research professor also.
Because I forgot to mention, our projects have scholarships for PhD students and visiting professors.
Yeah.
Well, the other question is about projects in our operation, and while talking about projects, we must talk about funding. And I would like to understand, well, considering your side, do you have some funding institution in your university or in your country that you could have funding for projects?
Yeah, sorry. Yeah, we have there's some research funding like Korea and Brazil. There is some common project funding is always every year is opening, and in our university, in point of view, that we have our 4 research lab. That is the 4 research lab that is completely based on the industrial projects, and they are talking about government projects. We are bringing those things. So yes, we have that type of funding also.
Well, that's very nice. And so we have presented a very hot topics about research. And so we can complement your research with our side, right? And we can submit a particular project for open calls together in the future, right? I think that's a good way to follow. So in this moment, I would like to open the word for other professors like Professor Rodolfo or Cristiano, or maybe Professor Madhu, if you have a question for us, for example.
No, I think we have like a lot of projects. So I saw that a lot of project is going on that related to the blockchain in agro, blockchain in the milk dairy one. So all this corona drug is coming on, right? There's Pfizer and anyone. So how much drug is a supply is going on, and how many people are touching and those drug tracking those things. And also I am trying to working about the I'm sick, so I'm taking a drug packet have some sensors. We can put those sensors so they can alarm us that like some people have Alzheimer people, they forget to eating the drug and those things. So we can provide that that packet of the drugs, the sensors, they have only signals, green and red signals. Like if I forget to eat my drug on the day, any day, so that they can inform, we can see that packet and we can got it. Oh, I forgot the eating my drug. So that type of some technology we are talking, we are proposed already some projects for the applying in the some medical company industries in here. So some medical company industries in here. So the result is not comes project result, but we are working on that things also. So that is also one good field, and for the blockchain purpose, we can track the drug delivery and whole supply chain management about the drugs and what type of chemical is involved in that drug and those things. Like as you mentioned about the chemical blockchain, you are implementing chemical industry, right? It's your project one. So that chemical industry, we are working about the drug company for the drug purpose to how to we track the whole process. So that type of also some projects we are working on, and I didn't mention those projects according to my project details in my presentations. So, but yeah, we are working on that things. And in agriculture field also, we are working we tracking field in the field. We are deploy the sensors, and from the sensors, data will be going to on the blockchain server, and from there, every farmer has some applications. In the application, the farmer can be detect that what type of like farming we need to do in that particular field based on the field status. Like, and when first we are start the farming, then whole farming beginning to growing things, sensors data will be giving the data to transmit the data with through the blockchain to the farmer's mobile. Farmers don't need to go every time on the farm, and he just is sitting in the place and he find it. Okay, now we need to put the waters, we need to give this chemical for our farming, and according to that, once the farm is completed, so after the completion, he can check that quality of the farm, and then is also put in his information that my farm is ready, and from there he can share his farm information, what type of chemical he use in their farming with the government and everyone's. So they can government will check their farm quality and put it the grading. Okay, you have the A grade A grade food or B grade food, and then when he go for the market, So retailer or distributor and as a consumer, when we are going to buy, so we just have the barcode, and according to that barcode, we can access whole information from the blockchain. So we can access and we can find out the, okay, this food, what food I'm eating, how much is chemical is running on this food, and how much supply, how much quality is mentioned by the government, what is the, and then after when I'm eating and I feel like food is good or whatever, so I give that grading about the feedback that based on like star, 1 star, 2 star, and 4 star. So based on that things, the farmer get the grading, and he get the, like, farmer has not that enough money, right? Who is doing only farming. So they can, based on those grading, that I produce a great quality of my food. So from he get some credit points from the government, and when he going to start about the new food, new farming. So based on his credit, those credit and crypto information is also stored in the blockchain server, so they can get it. The whole informations are, these are the A grade farmer, they are producing always A grade food, and based on his credit is high, so we can get it. The investors can also invest their money on that farming, and government also can give that some seed and all things on that as a benefit based on their credit. So we already did this project, so we already applied about that patent. So yeah, those two project is also going on with us in current time. We are working on those things. Yes. So now if anyone has any questions, then yeah, that's enough on my side.
Oh, that's a very nice initiative, and thanks for your explanation, Professor Cristiano or Professor Rodolfo. So I have my questions here, and so I can continue.
Yeah.
No problem.
I can actually, I have a question, because we have seen blockchain being used for all sorts of projects related, of course, to authentication of data, distributed authentication of data, because this is the main focus of the technology itself. And so it began with financial transactions. That's the Bitcoin everyone knows. And we have seen medical data, Industry 4.0, as we have seen. And I would have a question. If you have seen recent work that combines more the blockchain as instrument to store information and the machine learning side of things. I will give an example of a work I have seen related to use the blockchain as a storage, distributed storage for learning models to use the concept of federated learning, where you have the idea that each partner in distributed processing will train a small part of a learning model, and a central entity or the partners themselves will use these models to combine on a bigger learning model with higher accuracy and better performance. So, and the idea of using blockchain, of course, is to try and avoid the learning model to be falsified or to be inserted some kind of false information that may degrade the model. The typical peer-to-peer attack scenarios that we have seen in past research on that field. I would like to know if you have seen other work on that, on this area, if maybe you have some projects in these fields too.
As it's a question for me, right?
Yes.
Yeah. So as I already mentioned, that is a self-driving car, right? So in self-driving car, we consider about the communications. On self-driving car, there is also machine learning things. We are using reinforcement learning, and we trained our vehicle to be self-drive, and we bring it the whole safely and for the source to destination where we want to go for the human purpose. So one applications we can use in the self-driving car. And other applications as anywhere where is the lot of data is generating, we need to control those data. As my point of view, like even though machine to machine in the industry have also so many automation things, right? So we know we don't need to use the every time so automations we need to give the instructions to, okay, bring in the industry, we bring this packet to and put it that location. So we just train those whole informations to our machine, and those information once one work is done, so for the next work, he can get the data from the blockchain instructions. We can make the blockchain server connection with the blockchain server, and he can access that. Okay, what is the next process? We can do that. If as much as repeated work, so those work we can also put in the server, and that machine can be take it, because that big issue about the machines, we have need to think about the energy and consumption and the storage power. So as we create the light machine, so we just give that some communication network. Communication is small device with connect with the machine and connect with through the blockchain server. So blockchain server give that instruction, and he can access the instruction we make that some standard like some smart contract and those things. So he get the instruction from, okay, what the repeated work I need to do it. He don't need to calculate every time the by automation things for the machine itself. So that is also can be one application for the industry point of view. And another things like, as I mentioned, to automation like self-driving car, we are already working on things. So wherever we data, so we don't give that as artificial intelligence. We just need to teach that how to access data and how to process those data. And all data we're going to store information we're going to store on the blockchain server. So any application about the AI, that type of also one best example for the applications point of view.
Thank you.
Yeah, I just want to comment on some recent and interesting application of blockchain. We had just a couple of weeks ago the elections in the US, and we are here in Brazil also having elections for mayors. And the blockchain is a very good tool for using in voting systems. We recently, Professor Rodolfo and I, we advised a master's student that worked on a proposition of a voting system, thinking of the Brazil reality and what you can do with it. And it's very interesting because we have some law restrictions in Brazil. We can't have an online vote because one of the restrictions is that you can't have a condition that someone can influence your vote. So we need a place that the people has to go and vote there. And we very, very interesting electronic voting system that works very well, but it's totally offline. So blockchain is a very good solution for this transition from the offline to online. And so this could be a very good example of recent application, the context that we're living today. And in the US, they question a lot the process of voting and the validity and the security. And blockchain seems to be a very good tool for employing this area. So this is one of the examples I'm thinking about.
That's I'm agree with that things. Yeah. So as I mentioned that wherever we have think about, even though wherever we're going to use the artificial intelligence also based on the data analysis, right? So those data where he get it, that analyzing things. So those data he need to get in some access. We need to teach the machine for any instructions. So those data can be accessed from the blockchain. That's an easy way.
So
exactly.
Well, following here, I have not especially one question, but I would like to see the viewpoint of Professor Madhu, right? So we have talked about blockchain in smart cities, in special blockchain of vehicles, and also we have talked about blockchain in supply chain, right? And so I'd like to see your viewpoint about problems related to interface and portability in blockchain networks.
For the blockchain network interface or in the side of the blockchain?
So I think, for example, talking about supply chain, we have different companies and we have different players and they must be connected, right? And so here for me, we have a real problem of connection because we have one interface. Okay, I am company A, and I can work with this kind of interface, and okay, I am company B, and I don't understand this kind of interface. So here we have a problem, and in this moment we don't have a unique interface well, API for programming blockchain, right? So I'd like to understand your viewpoint in this issue.
In this issue, like as I mentioned, like every industry and every connection has a different work style and different environment, right? So we need to make it that particular environment there, all we find it what is the common features, what is the common things between those environment. And even though like I'm working with the as a medical industry, and those another one is the marketing industry. So we need to provide that connectivity between that, right? So what the features is marketing doesn't require the whole information about the medical industries things. So we need to make it some consensus, like that consensus comes from here. So we need to make some concessions between all our stakeholders, all our contenders who is involving in our projects or our work. They will be agree on some mutual. Okay, this is this interface is just providing the filtering about the informations. We don't give that whole informations to marketing team. We don't give that whole information about to medical team, that drug industries, or we don't get it the all information, because there is like some financial and those issues. There no one going to be disclose those things. So we make it some filtered informations interface. There can be just we can require what information we required. We can access those things. So as I give that example of this farming one, right? So in farming one, like farming is always going to update after 4 months or 6 months. Is whole one farm is completed the whole food, right? Like if we are producing the wheat or producing the rice, so it will be take the 4 months or 6 months. Within a 6 month, that whole process is going to be completed. So once the process completed, so what the status of that on that field, those data we don't require for the farmers, right? So farmers can be make that filter. Okay, this we make that blockchain. Some farmers related data we can remove it. From some government data related filter information, like what government giving the certificate to that farmer, that product farming we can store for the permanently. And what is connection between the that marketing and retailers. So we give that marketing and retailers, we give that only that barcode, and he can access that all information from the government. He don't need to contact with the farmers. And farmer, according to that, once farmer is that data format as don't have that much amount of payment of that much amount of storage things, so he can be remove the all information, and he can upgrade, he can override those informations for the next farming. What he's going to do the next farming. So based on their own, again, sensor data, is receiving those sensor data. So my point of view interfaces, we make that filtered information filtered between the particular required information about that particular our stakeholders. We don't. So current time in blockchain, who is the involved in that blockchain server? They have stored whole data. That is also big issue. We about to filtering, storing whole data. That is we require the whole storage, and then when we require some particular information, we need to analyze the all data, and we need to do those things too. So that's way we can divide in the filtered way. So we can divide in we don't need to divide all for the outside of the blockchain. We can provide that filtering within the blockchain server. So as that, as a professor mentioned, that is also one application of artificial intelligence. We can use the AI within our blockchain server. So in the blockchain server, we make that some intelligence analysis, data science or data analysis things to be which information is related with the which particular stakeholders, and they just provide those things. As that is mentioned in the one big issue is all information when I'm going to communicate within the blockchain server. So my information will go with that mathematical problems, right? That's for the consensus, right? So, but what information I'm broadcasting, that information is always in plain text. That information going to be to access by all my nodes who is involved in that network. That I don't want to disclose that things. So for that, we can use that homomorphic algorithm or some another new crypto encryption algorithms that can be provide us to once when I broadcast me and my destination, source and destination can be changed in the decrypt that information. Others node, they just verified the who transmitted node. They don't need to verify to the our information. They just verify the transmitted node. Node is the legal. They are the peer-to-peer. They are the real node in our network, is not from coming from outside. So these are the some issues are we can be solved, like as I mentioned, for one, information filtering, some encryption mechanism that can be used for the transmission things. So it will be useful for the giving as your answer of your questions, I think, right?
Yeah, that's a nice discussion.
Yeah.
So in this moment,
Yeah.
so Professor Cristiano.
Sorry. Yeah, I will just complement another issue related to interoperability that's very important, especially in the health area, is the use of standards. Because generally, I don't know how it is in South Korea, but here in Brazil, generally each hospital uses their own health information system with different format for storing data. So they have to agree upon a common standard for interchanging information. So we have international standards like the HL7 FIRE. We use it a lot here, and our government is using it here now. And the OpenER, which is also a standard for a clinical data acknowledgement. And you can develop all your clinical database based on these standards. So this is, I think, complements your answer. In some areas, you have also to adapt some standards because to make the communication easier between partners, because there's a lot of information and each one has their own proprietary storage system, and for interchanging that we also have to agree on some common ground. So I just want to compliment on that. Sorry, Hig, if I interrupted you.
Nice. So we have received 2 questions from our YouTube audience. So PhD student named Emiliano Monteiro. So he has 2 questions, as I said. The first, could the government dictate what the data exchange format will look like? So, Professor Madu.
Yeah, so for the government dictate what the data exchange format. So actually that is the depend on the different governments rules and regulations status things. But as if we are not interrupting government rule and regulation, we are not destroying, we are not breaking any rule and regulation according to governments. Every government has their own law. If we are not doing anything breaking those things, so I don't think so government going to be dictate our data. Even if I'm talking about in the republic places, right? So as a general way, so if anything is not going for against the government, against to the law of the country, so no government going to be interrupt our data, as I believe that is.
So the other question is related to, could access to information be based on trust relationships with a particular domain?
Yes, we can. If a particular domain, if they have a trusted members in that domain, so they can access the informations. No problem for because as I mentioned, like within the blockchain, everyone is a trusted within all stakeholders is a trusted. So if I require some particular information, then I can ask to that in the another nodes. So I can access those informations. And the whole information is not from, I'm talking about within the network, not out of the network. If out of the network, that you need to prove that, yeah, you are the really trusted person or trusted node who not going to misuse the informations things. That's.
Yeah. So I share your viewpoint. So here at Unicinos, we are working both in the application viewpoint and also in the resource management viewpoint on a blockchain applications, right? Yeah. So, well, we have problems related to regulation, API, scalability, energy consumption, price of the resource, transactions cost. So, Professor Madhu, I'd like to see your viewpoint about what is the biggest open problem on adopting blockchain worldwide.
Biggest problem adopting a blockchain in a worldwide, as I already mentioned so many things. So that is good questions. So for the worldwide, that is the big issues to feasibility of the applications. We need to modify those. The main issues, we don't have any standard, right? So whatever application we are going, that we need to change everything according to our applications. Even though we need to, as I'm using for our self-driving car. So in the self-driving car, I modified my whole consensus algorithm that because sometimes we cannot drive, we are just we are standing. So we need to consider those things also. Sometimes currently we are paying whole insurance fees about to our car, even though we are not driving whole year, but we are paying to whole year's insurance for the vehicles. So those all points can be considered. So according to, based on the applications, different applications and different the requirement of the applications of is changing to the blockchain to modifying. We don't have that universal application as a Ethereum and Hyperledger. They are providing to platform, right? So they just providing the platform, but in the platform, what the application we are going to use those platform. So we need to think our requirement. As if you see my PPT, I already mentioned those things. So I just going to. Yeah, sorry, I forgot to. I already mentioned that things, the basic of approaches like adoption approach. There is a discover, analyze, define, and implement educations. Those 5 stage, right? So first we need to find out the which domain we're going to use that thing. So that worldwide also we need to discover the our application is really useful for that particular application or not. That blockchain is really useful for that application or not. Like as we communicating that thing. So some small, if we are going for some small applications within a home, we are using so many IoT devices, right? So that thing is a human can be remember that what devices we are using. So there we don't require. So our blockchain, because blockchain has that is a lot of expenses and energy consumption and those so issues. So according to domain, we need to decide, right? So worldwide is the problem is like finding the domain, which domain is really it is useful and which domain is just like for the people are using for the that can be try, and modifying according to that domain is it hard. Like if we're using for the some small element, for example, within a home, if we are going to use our blockchain server, so we need to consider about that. Okay, in a home we have the 5 people or 4 people, so everyone can be accessed. Everyone is valid. They can come to inside of the room, our home, and cannot come. So they have also like they don't require. We have the so many applications. We don't make too more energy cost and those effective. So we don't require things. But yeah, worldwide is more things like everyone word. We think about the cost, energy, and the domain. That is the basic issues.
And so each domain has its own requirements, of course. Yeah. So we must adapt the blockchain on that context. So, for example, here at Unicinos, we have research on choosing what must be saved in the blockchain and what must not be saved.
Yep.
Right? And so we can gain performance on that. And also we are working on blockchain benchmarks. So, for example, we can modify the number of blocks, the size of the blocks, and the number of the nodes. So the idea is to optimize the performance of the blockchain while looking at this kind of parameters. So we have research on that direction.
Yeah, optimization is a big issue for the.
So, yeah. For example, as I said, you have a lot of parameters that impact the performance of the blockchain, right? Nodes, size of the blocks, number of the blocks, and so on. Time, right? The timers, and so we must turn off them in order to get performance.
Yes.
Well, I think that's we have a good discussion, and so Professor Cristiano, Professor Rodolfo, you have other questions? No? So, Professor Madhu, please, I'd like to ask you about your final considerations for our workshop.
Thank you very much for inviting me this, Professor Rege, Professor Cristiano, Professor Fadu. That is for really, Fabio. That is really very nice meeting and very nice discussion for our research, for the future research scope and research collaborations. We have find it like so many, we have the common research goal. We are already working on it, so many common research projects also. So I think we will work together in future and we will get it some good result for the, not for us also, for the society also. So, and for our countries also. So it will be very helpful. Yeah, and thank you very much for organizing this. That is the Korea and Brazil forum. I think this is very nice forum. There we can discuss our current work also and the future perspectives also. We can merge where we can possibilities and those things. So really thank you very much for inviting me and this event. And I will be happy to go for further research, our collaboration and discussions more. So please keep in touch, and thank you very much, Professor Rigi, Professor Cristiano, Professor Rodolfo. So thank you very much, and others who is already joining our meetings. So thank you very much for listening to me. And if you have any questions, so please, you can email me and we will discuss on, I'm open for the discussion for any times. Yeah, thank you.
So Madhu, for this wonderful workshop. And well, you and all faculty members of Wuzong University, so you are always welcome to our university. It's a pleasure for us to receive you in our event. And so, well, we will continue our partnership, our collaboration in terms of projects together, in terms of collaborations on articles and book chapters. So your participation in our research is very, very important for us. So it was a great moment for our audience, for all the Unicinos team. And well, we decided to visit you in next year in South Korea. So in Daejeon, right? It will be a pleasure for us to visit you again. So thanks, Professor Madhu. Thanks, my colleagues, Professor Cristiano and Professor Rodolfo. Thanks our audience from YouTube. And I'd like also to thank our backstage team that is working very, very hard for enabling this workshop. So in this moment, the workshop is closed. Thank you very, very much.